Next we have Scott Michael. Scott Michael's going to talk about 100 gigabit Lustre WAN. He's an astronomer at IU. Scott Michael.
Thanks, Steve. Wow, what a great log this has been. I'd really like to take an opportunity to thank Mr. Sims as the program chair and the organizers and the vendors. What a great program this has been so far. So today I'm going to talk a little bit about the experiences that we had with 100 gigabit networking over the wide area. Last year I gave a talk on distributed workflows over 10 gigabit networks. So this SOC has 10 times the bandwidth. You'll have to decide if it's actually 10 times better. What I'm going to start off with is the experiences that we've had so far with our distributed workflows with Lustre WAN, and then move on to what we did at supercomputing with the 100 gigabit networks, and some of the lessons that we learned from taking LNet measurements and doing file system tuning to really get the peak performance that we could. So, as Josh said earlier, we've been doing wide area Lustre for quite some time at IU. And from a researcher perspective, so I've used the file system as both a user and an administrator. From an end user perspective, this really lets people access their data very easily from a multitude of different resources. So instead of having to worry about, where the data is initiated, where you're going to compute against it, how you're going to visualize it, maybe using different computational resources, the data just sits in a single place, and all of your resources can then mount that wide area file system. So you really get to have the entire data lifecycle all at a single location. And this is really great for the users. And so we've been doing that for several years now and had a lot of experience mounting the data capacitor WAN from lots of different sites. So we currently have a wide distribution of remote clients geographically, and we've had clients anywhere from 1 gigabit connections to 10 gigabit connections, all the way down to a few megabit connections. Those guys aren't super happy with us, but it's really the network's fault, is what we tell them. And we connect across a broad variety of networks. So one of the big challenges when doing Lustre over the wide area is that you're sort of at the mercy of the network, and you can be spanning multiple national, international, regional networks. And the whole end-to-end network really needs to perform well in order for you to get good performance. And we've, mounted file systems from a few milliseconds in latency up to, over 100 milliseconds in latency. So last year we did an interesting experiment. Steve Sims, Robert Henschel, and some folks from ZIH, Michael Kluge, and his team worked on putting together a 100 gigabit testbed from Freiburg to Dresden in Germany. This is a fairly low latency link. It spanned 60 kilometers for their initial tests. They were able to bump it up to 200 and then 400 kilometers by putting a bunch of fiber in the machine room so they could do some further testing, which is a bit artificial, but you get the idea. And for the 60 kilometer measurements, they were able to get a peak throughput of 10.8 gigabytes per second, which is quite good, 86% efficiency. So the setup here that they were using is, a cluster, if I can, in ZIH in Dresden and one in Freiburg. These are both IB interconnected clusters, and so they went through LNet routers on both ends, which also functioned as the OSS. and then some a DDN SFA 10K, and then on through the 100 gigabit path. So that was quite good, but it's a fairly small distance. So what we wanted to do was sort of up the ante and add in some more over a longer distance, thereby adding in a good bit of latency. So IU put in an entry into the SC11 SciNet Research Sandbox to demonstrate cross-country 100 gigabit cluster WAN. So what we proposed to do was to set up a file system, one at Indiana University, one at the show floor at SC11, and do a series of networking benchmarks, LNet testing, file system benchmarks, and a suite of real-world scientific workflows that our users at IU run on a day-to-day basis. So we got a group of scientists who have moderately to high I/O workloads, and we wanted to put them on the system and see what they could get out of this 100 gigabit link. So our setup looked like this. We had a small cluster at either end. Basically, the setup is mirrored both in Indianapolis and in Seattle. There's a SFA 10K connected to the 16 OSS and 30 clients on either side. This went up through the 100 gigabit path. We also did some open flow testing, and that's what these switches represent, but I won't be really talking about that too much. The total distance was over 3,500 kilometers, and that gave us a latency of 50.5 milliseconds. So how did we do? Well, we did okay. There's always room for improvement, though. We were able to get, using hypertests, up to 96 gigabit. Using an IOR benchmark, we achieved 6.5 gigabytes a second. And our mix of real-world applications, we were able to utilize, most of what we were able to benchmark at 6.2 gigabytes a second. Now the caveats here are, well, there's a very long list of caveats, but the things that I'll say is that we had a relatively small cluster on either end driving this link, and the total amount of time that we had was 20 hours at SC11. So this 100 gigabit link was shared among all of the Sandbox participants, and you would get 1 hour at a time at some random time in the very early morning. So sleep was not an option, but we got what we got, and we did pretty well considering the circumstances. In addition, this cross-country link had been lit a couple of weeks before SC11. So the path from Salt Lake City to Seattle was, brand new, about a week old. And in addition, we were only able to clear the network from Seattle to Indianapolis in that direction. We could never get peak throughput back from Indianapolis to Seattle. So bidirectional, the network was not fully capable in a bidirectional sense. So considering all of that, I feel we did pretty well. So here's the suite of applications that we ran, and they come from a wide variety of scientific disciplines, from astronomical simulations to computer science profiling codes to real sensor data, CFD, molecular dynamics, bioinformatics, and on and on. And so we got a real representative sample of what our users do on a day-to-day basis and how they would be able to use such a system in their everyday work. So what did we discover? Well, if you do WAN file systems for a little bit, you'll quickly realize that you always need more RPCs than the default. Because when you're talking about latencies of tens to 100 milliseconds, you have to have more RPCs in flight than the default of 8. So the first thing we did was obviously to increase that default setting. It's pretty easy to show that the max throughput you can expect out of any link is given by this equation here, where the number of RPCs times the payload divided by 2 round trip times. So in order to take for a link of given bandwidth and latency to maximize that, you need to have a number of RPCs greater than this. So for our setup, that was about 5,000 RPCs, which isn't a huge number, but when you're considering that it's coming from 30 clients, you need to set the max RPCs in flight pretty high on each client to achieve that. So we did that, and surprisingly enough, well, surprising to us at the time, we didn't really see great performance. So it turns out that the other things that you have to increase quite a bit are credits and peer credits. Now, this is something that we hadn't had a chance to test a lot over the wide area, and it can be. We knew that it was fairly important in some settings for IB and whatnot, but we hadn't had a chance to really do it to do the testing to this level. So what you see here is that for a variety of settings in peer credits, we're looking at basically the number of RPCs. So we did LNet self-test, and roughly speaking, the LNet concurrency is equivalent to the number of RPCs in flight. And so for the black line here, which is 8 peer credits, you see that past 8 RPCs in flight, your throughput basically levels off. For each bump up in the number of peer credits, you get up to the theoretical maximum from that equation I showed a couple slides ago, up to the number of peer credits, and then your performance starts to level off. Now this is what we saw for a single client to a single server, because that's sort of the simplest setup where we could collect the data and see what was going on. When we went to the whole system, I mean, so this behavior was, if you actually sat down and thought about it really long and hard, you would basically come to this conclusion on your own. We just hadn't had the chance to do all that. So we expected the same sort of results out of the whole system, but that's not necessarily what we got. So for the single client and server, we were able to get 1092 megabytes a second throughput, which is almost 90% efficiency. When we looked at the whole system, we saw that changing the credits and peer credits in conjunction with the RPCs in flight did improve things, but not to this gap here is the difference between what we expected and what we got. And so it wasn't quite to the level that we had hoped. We were still able, to get LNet numbers for the whole system at 9,000 or so megabytes per second. Okay, so I'm going to wrap up here because I know everybody is really hungry for lunch, and I hate to keep you from eating. So the whole point of this is that 100 gigabit networks are currently deployed through Internet 2, and will soon be fully covering the nation and internationally as well. And one great way to leverage the networks that we have is to use Lustre over the wide area. It simplifies the user's life. It makes things much easier for distributed, geographically distributed workflows, which happen a lot more often than you might think. So when you go to deploy your very own Lustre WAN system, you need to be aware of these settings for RPCs and credits. And you also have to think about how you're going to balance the needs of your different clients. So once you get to having local clients as well as regional and national and even international clients, changing these settings can impact each of them differently. And so you have to find the right mix. So with that, I will conclude and take any questions.
Questions for Scott?
Everybody's hungry.
No, can't blame him. All right. Thank you, Scott.
Thank you.